Okay, it's 6 o'clock and we've got an amazing panel to hear from today, so I'll get going as quickly as we can. So welcome everybody, thank you very much for making your way here. I don't know if you're like me and you spent a certain amount of time circling the building being told the entrance was on your left, but glad to see you're all here. My name's Gina Rippon and I'll shortly be telling you why I'm here and what I'm doing. But before I get going, I've been told to give you the usual housekeeping notes. No planned fire alarm tests this evening. If it does go off, please vacate via the exits at the front and back of the lecture theatre, and the RSS fire marshals will guide you to the outside meeting point. Okay, so hopefully we won't need to remember that. So again, welcome to this second event linked to this project called Noise in Neuroscience, which you'll be hearing a lot more about later. And the team that I'm working with, we began about 18 months ago, I think. Pandemic has affected my experience of time somewhat, so sometimes it feels like it's been going on forever, and sometimes it feels like it started very recently. The first event to discuss the findings from this project was held with the Association of British Science Writers back in July. Turned out to be on the hottest day of the year, where all the trains couldn't run because the rails had buckled, etc. So here we are on this second event, on possibly the coldest day of the year so far. So if there's a third event, maybe there'll be a plague of frogs or something like that. But anyway, hopefully they aren't cursed events. But I would very much like, first of all, to thank the Royal Statistical Society for hosting us and for setting up the venue and for organising all the registration, etc. Thank you very much indeed. And I'd also like to thank my university, Aston University, which provided some money for these events, and also the challenging pseudoscience at the Royal Institution. And I realise there's a very important comma missing after challenging pseudoscience. So the group is actually called Challenging Pseudoscience at the Royal Institution, and they also provided some funding. Thank you very much. As you can see, we've got a fantastic lineup of speakers and me, who I've listed here, and I'll do very brief introductions as we get to each of their talks, and hopefully they'll tell you a bit about themselves. I'm now going to move on to the second slide and come back to this at the end, because I think this, for me, summarises what this is all about, what the project is about. It's about the chain of communication of science research. One of the things I'm going to do is say, actually, what this talk is not about fraud, it's not about disinformation, it's not about intention to deceive, it's not about us telling researchers how they should be doing their research, or journalists how they should be writing about it. It's just saying we would really like people to be really careful about how they present this work. So there is a chain of communication. At the beginning, we see a depiction, which was a cartoon that somebody did of me giving a talk in Canada. I don't know if they were drawing attention to the fact that I'm vertically challenged, so I'm standing on a ladder. So we have researchers doing this work into sex-gender neuroscience, and I use the term sex-gender. We may come back to that later, but that's an indication that these two aspects of this research are very entangled, and it'll probably be something that others will be touching on. So we have well-meaning researchers doing this excellent research, asking specific kinds of questions about differences in the brain. And then they write up that research and they publish it in highly esteemed journals, like Nature, for example, they hope. And so that is actually the origin of understanding this work, is published in these journals. And then it moves on via, perhaps with a bit of help from the university PR department, who likes to write headlines and do a bit of marketing and saying, you know, it's great that we've had this researchers in our universities publishing these papers, etc. And they go into mainstream newspapers, mainstream media, science journalists who pick up particular stories, run with those stories, interpret them for their readers, maybe asking other researchers, what do you think of this paper? I've got a deadline at 4 o'clock. Please, could you go through the whole paper and tell me what you think, etc. And then you get the headlines. And the reason that this talk is called At Last the Truth, because it seems to be very characteristic of whenever something popular about sex differences is published, we get headlines like, At Last the Truth, or Proof at Last, or headlines like, Men have bigger brains than women, research reveals. So there is a kind of hype immediately embedded in how this story is told. Of course there is. I mean, newspapers have got to sell, etc. But it is sometimes a problem, and there is this implication that there is a truth that's already established. All researchers are doing is actually catching up at last with what is going on. And people are reading this, and it's confirming what they already think, and that's great, and we can all believe what we like to believe, the differences between men and women. And then that goes on from the mainstream media to via all sorts of social media, perhaps, to what I've called the kind of Mars and Venus neurotrash type books, which we can all sort of laugh at and roll our eyes and have a good go at, and a lot of people, particularly me, have had a good go at those. So we can all say that it's a shame that this kind of poor writing has emerged from this, but as scientists we know it's not based on truth. But unfortunately it does have quite a big impact. A lot of people I speak to have read these sort of books. That's where their knowledge about the differences between themselves, males and females, or their children, or their employees comes from. So it does have an impact. More importantly, and I think this is why it really matters, and a lot of people say in terms of what we're talking about, but this is true of all science. Why do you think it's more important for the kind of science that you do that we really make clear what it is that you're trying to say and what people should be hearing? And that's because this kind of work feeds into policy decisions. So a recent inquiry on diversity and inclusion in STEM subjects, why are there so few women in science, for example? They are looking at that kind of research and reading how it's been interpreted. And similarly, the Fawcett Society recently looked at the effect of stereotypes in the early years. Makes really worrying reading, actually, and all sorts of other statistics indicate that the kind of stereotypes we have about how males and females are different are really important to be aware of. And researchers need to bear in mind that they are at the beginning of this chain, and at the end of it, there's this kind of impact. But what we're going to be talking about this evening is the beginning of the chain, what researchers should be thinking about when they're writing. And we need to bear in mind, particularly with early career researchers, that there is this big word called impact. So you're supposed to prove that your research has impact. And for lots of universities, and particularly perhaps the marketing departments, impact means getting a publication or a mention in a mainstream science, or getting on Horizon or something like that. So there is quite a pressure on these researchers, and they have to publish or perish, to actually hype up what they're saying and maybe focus on the significant differences they found, and perhaps ignoring the ones which didn't quite fulfill the hypotheses they'd made. And so immediately you get this big body of research which looks like scientists have proved there are sex differences, and sex differences in thousands of titles, etc. So, and also the journals want, their impact factor to be as high as possible, so they want lots of people citing it, and they want, people paying attention to what's published in their kind of august pages, etc. So the focus that we're going to talk about today is really why we need to be really careful in this area about how we write about this kind of research. And also as readers, how we need some kind of filter to say, looking at what this person has said, is that really justified? If somebody's got less than 1% of the comparisons they made are statistically significant, and that's a whole other story which we may come across later, does that really mean that we can refer to those differences as profound and fundamental? So going back to the earlier slide is just to draw attention to the fact that we have a program where we're going to be talking about the pitfalls in sex, gender, neuroscience research. And that's really, for example, are we asking the right questions? These questions have been asked since the end of the 18th, beginning of the 19th century. A lot of the time, they weren't even questions. The research was actually about proving the answer they already believed was there. So that's something. But how is it described? Is it described as saying, yes, this is the assumption we're making, and look, isn't it amazing, we've actually come up with a measure which proves that that's right. So we need to look out for that. But we also, the second part of the evening is, or the middle part of the evening, is the fact that science has already started to police itself, if you like, or to offer help, and to say there are pitfalls in all sorts of science, but in this science in particular for this evening. What are we doing about it? And we have somebody from the Science Media Centre, who some of you may be familiar with, who's going to be talking about what they do in this area. And my own team, the people who've actually done the work, are going to be talking about the guidelines that we've come up with, which we hope will help people solve the problems or avoid the pitfalls in this particular area. And finally, we're all going to get together with representatives from the press and from the journals to say, what is it that we researchers are doing wrong or should be doing in order to prevent this sort of Chinese whispers effect, where at the end of it, there's all sorts of sustaining of stereotypes and misrepresented reports of the research, and all sorts of beliefs which are proving not to be wholly supportive of individuals. So I think with no more ado, I shall turn immediately to Daphna, who is going to talk a bit about the fact that we might not be asking the right questions, and that is something which is quite important that we should talk about. Thank you very much. Find it for you. Here we are. Oops. It's gone back. Right. Slideshow from beginning. Yep. Okay.
Thank you very much.
And I'm going to keep you to time.
Okay, you should. So thank you very much, Gina, and good evening to everyone. I want to start my talk about going beyond the sex binary with a study that started me thinking beyond the binary. And in this study, the researchers describe a sex difference in the effects of stress on the brain, and specifically on the density of dendritic spines. So you see here a piece of dendrite, and the small dots are dendritic spines. And they reported that in males, 30 minutes of stress led to an increase in spine density, whereas in females, it led to a decrease in spine density. For the researchers, this was yet another example of sex differences in the brain. But I, looking at these images horizontally instead of vertically, noticed something very different. I noticed that the effects of sex on the brain may be opposite under different conditions. So what was typical of males in the non-stress conditions was typical of females following stress. And what was typical of females, non-stressed females, was typical of stressed males. And just to help you realize how remarkable this finding is, think of your reaction if I would tell you that 30 minutes of stress would be enough to change your clitoris into a penis, or your penis into a clitoris. Now, I was hoping you would be laughing at that point. Thank you. Because obviously, this never happens in the genitalia. But it does happen a lot in the brain, and there are many studies reporting such reversals of sex effects in the brain, in many regions of the brain, in many different measures of the brain, and following different manipulations. Even simply housing rats one to a cage compared to several to a cage can reverse some sex differences in the cortex. And when we look at these studies together, we realize that these interactions between sex and other factors, like stress or housing conditions, could be different for different brain measures. So the same manipulation that reverses a sex difference in one brain measure may abolish or create a sex difference in another. And when we look at all of these studies together, we realize that they challenge the sex binary. And I want to stay with this slide for a few minutes and to show you what we can learn from this slide or from these findings and what we cannot. So the first thing that we can see here is that there are sex differences and that something related to sex affect brain structure. And there are many studies in animals showing that sex-related genes, and to a much greater extent hormones, affect brain structure and function. Usually when we hear this, we immediately continue to conclude that this must mean that there are male and female brains. This is the binary framework. However, these studies suggest otherwise, and I will suggest a different way of thinking about the relations between sex and the brain in a few minutes. The other thing that I want you to notice here is that even though sex-related factors affect the brain, knowing someone's sex category gives you little information about their brain structure. In these images, we can see that knowing that a rat is male or female doesn't allow you to predict whether it will have high or low density of spines or receptors. Together, as I said, these studies led me to challenge the sex binary. But it turns out that it's not really easy to challenge the sex binary because, as Veronica Sanz so nicely put it, the problem with the sex binary is that there has never been an hypothesis or a theory to test. It is an epistemological framework that runs behind, above, and beyond particular theories and research projects. Within the sex binary framework, the taken for granted starting point is that there are male and female brains. This dictates a research method of looking for sex differences. And when these are found, then they are taken as evidence for the existence of male and female brains. And this self-maintaining belief system is very evident in the comments of this anonymous reviewer who wrote, "The usefulness of the dichotomization into female and male brains stems not only from its biological reality," okay, let's go home, "but from the fact that sex differences of all sizes and kinds exist at every level of brain function, not just regarding human brain anatomy. The collective evidence, the existence of sex differences, still overwhelmingly warrants categorization of brains as belonging to different, if often overlapping, populations, that is, as female and male brains. And this same logic, assuming that if there are sex-gender differences in the brain, this must mean that there are male and female brains, is also very evident in this very famous image that Gina also had on her slide. This is a summary diagram from a study of the human connectome, in which the researchers assessed the strengths of over 9,000 connections and found differences in several dozens. The upper panel here in this image summarizes all the connections that were stronger on average in men compared to women, and the lower panel, all the connections that were stronger on average on women compared to men. The color code is blue for intrahemispheric connections and orange for interhemispheric connections. This slide, or this diagram, as well as the accompanying text, reveals the author's assumption that these are the typical male and female brains, and that what's typical of the brains of men is to have male-typical connections, and what's typical of the brains of women is to have female-typical connections. Now, actually, this sounds like common sense, until we remember that what's typical of the brains of men and what's typical of the brains of women could be opposite under different conditions, and that these interactions between sex and other factors can be different for different brain measures. So even if I assume that at some specific point, let's say now, my entire brain is in the female typical form, then following such an event, such as stress, some of my brain measures will change their form, others will not, and I will end up with a mosaic brain. Mosaic in terms of having both male typical and female typical features. So this is the mosaic hypothesis I formulated over a decade ago now on the basis of this type of animal studies. And a few years later, we tested the mosaic hypothesis in the human brain, analyzing the structure of over 1,400 human brains. And we did different analyses. I'm not going to show you all of them, only one. In this analysis, we divided each brain into 116 regions, measured the volume of each region in each brain, and wrote it down in a table. In this table, each line represents a single brain, the 116 regions, the volume. To appreciate similarities and differences between the brains of men and women, we next used a color code to paint each cell. We used green if the volume of this region in this brain was relatively large compared to the volume of this region in all other brains, men and women combined, and yellow if the volume of this region in this brain was relatively small. When we were done, this is what we saw. Brains of men on the left, brains of women on the right, each line a single brain. Now, you don't need statistics to see that there are differences between the brains of men and women. At the group level, there is more green at the women's side and more yellow at the men's side. But brains are rarely all green or all yellow. Instead, each brain is a unique mosaic, no two lines are the same, of green, which is more common in women, and yellow, which is more common in men. So the question for me is not whether there are sex-gender differences in the brain. I'm also not interested in their source, nature or nurture, but only in whether they add up consistently within each brain to create two types of brains, male and female, as sex differences in the genitalia almost always do, and as is implicitly assumed to be the case in the human brain, or do they add up or mix up, if you want, in each brain to create unique mosaics? And I think that when you look at these images, this is quite clear. Now, I always show these images when I talk about sex and the brain because they help us go beyond the binary. They help us realize how it could be that there are group-level differences between the brains of men and women, but there are no male and female brains. In fact, when I look at these images, it seems to me that we all belong into a single, highly heterogeneous population of human brains, in which what's typical of both males and females is to have this unique combination of male-typical and female-typical features. And in subsequent studies, we applied different analytical methods to the structure of over 20,000 human brains to test this description and to better understand, once we go beyond the binary, how to describe the relations between sex and the brain. And again, I'm not going to show you everything, but only one analysis. In this analysis, we specifically contrasted these two views. One, that the typical male brain is different from the typical female brain, and the other that we all belong into a single, highly heterogeneous population, in which what's typical of everyone is this mosaic. And to answer this question, we used anomaly detection. So the logic here is you give an algorithm, an anomaly detection algorithm, a set of data, train the algorithm on the data, and then give the algorithm new examples. And for each new example, the algorithm needs to decide whether this is normal, belongs to the training set, or not. So we did the same with brains. First, we trained the algorithm on the brains of one sex category, so let's say on the brains of women. And then we gave the algorithm new brains of women and of men, and for each brain it had to decide whether this is normal or abnormal. And of course we then did the same, training first on the brains of men in this example. What would be the predictions? If the typical male brain is different from the typical female brain, then we would expect that if we train the algorithm on the brains of women, for example, then the algorithm would classify many more women as normal than men. And of course, the reverse if we train first on the brains of men. However, if we all belong into a single highly heterogeneous population of brain, then it doesn't really matter whether we train on brains of men or women. In both cases, we would be training on human brains. So we would expect a similar number of men and women classified as normal. So very different predictions with the two theories. To make sure that this approach could indeed detect two populations if they existed in the data, we first used as a positive control the facial morphology of two primate species, obviously two populations. And I'll go with, over the results with you quickly. So if we train the model on macaques, the first species, we can see that all the data points fall on the y-axis, meaning that the algorithm never mistakenly classified a capuchin as normal when it was trained on macaques. And similarly, when the algorithm was trained on capuchin, all the data points fall on the x-axis because it never mistakenly classified a macaque as normal capuchin. Okay, so the algorithm does a very good job in distinguishing that there are two populations in the data. What happens if we do the same, but with human brains? So these are the results, the exact opposite. So regardless of whether you train on the brains of women or men, all the data points fall along the y equal x axis, meaning that the number of men and women classified as normal is very, very similar. And this was also true for another data set. So this analysis and some other analyses that we have done show that the brain architectures that are typical of women are also typical of men and vice versa. We also showed in other analyses that there are large sex-gender differences in some rare brain types. And I'm not going to go into this, but just to give you an idea, this is important because it can account for some large sex-gender differences in some rare brain conditions, such as autism, for example, without assuming that a typical male brain is a little autistic than the typical female brain. So it provides a very different explanation to these differences. And the last thing that we managed to show is that sex category, knowing whether you're female or male, provides little information on brain structure and on how two brains would be similar or different one from the other. In other words, the fact that I have female genitalia gives you no information about my brain structure, and also it doesn't mean that my brain is more likely to be similar to the brain of this lady than to the brain of that gentleman. Up until now, I was talking about how the sex binary framework prevents us from thinking of other ways to describe the relations between sex and the brain. I want to now do the same, but talking about understanding the relations between sex and single brain measures. Within the binary framework, we ask, are men and women the same? Meaning, do they sample from a single underlying distribution? And if this null hypothesis is rejected, we conclude that there must be male and female distributions. So women are sampling from a female distribution and men from a male distribution. However, if you remember that what's typical of males and females may be opposite under different conditions, we could think of another framework, according to which men and women sample from the same two underlying distributions. So, for example, in the example with a density of spines, we can see that dendrites could be either in low or high spine density, and both males and females could sample from or exhibit or manifest the two forms of these dendrites. Obviously, conventional analysis by sex, like t-test or ANOVA, do not consider this possibility, but there are other statistical methods that can consider this possibility. And we use mixture analysis to ask the following question. Provided that the data are described by two underlying distributions, and not 3 or 4 or 10, do men and women sample from a male and a female distribution, or do men and women sample from the same two distributions? And we applied this analysis to 289 MRI-derived measures from over 20,000 human brains. And we found that for 99% of the measures, the hypothesis that men and women sample from a male and a female distributions respectively was rejected in favor of the hypothesis that they sampled from the same two distributions. And that for 87% of the measures, men and women favored the same distribution, either the high mean or the low mean distribution. And only for 13%, there was one distribution favored by men and the other favored by women. We used these few male brain measures that have a male-favored and a female-favored distribution to ask, are brains internally consistent in always sampling from the, say, male-favored distribution? And we found that they don't. Instead, brains are mosaics of measures. Some are sampled from the male-favored distribution, others are sampled from the female-favored distribution. So with a very, very different statistical or analytical approach, we reached the same conclusion, that brains are better described as mosaic of male typical and female typical features than as male or female brains. We also used the entire data set to look at the entire brain And specifically, we looked at the correlation between the posterior probability to sample from the high mean distribution across all measures. And you can see here that the correlations in men in blue and the correlations of women in red. And you see over 12,000 correlations. And the correlation matrix in men and women is extremely similar, meaning that whatever is governing the relations between any two pairs of brain measures, these set of factors are extremely similar in men and women. So in other way, again, conclusions that we reach with other analytical methods, again we see that sex category provides little information on brain structure. So I hope I managed to show you how these type of animal data refute or challenge the sex binary or our binary formulation of the relation between sex and single brain measures as well as the brain as a whole. And that how once we put this binary framework aside and can think outside the box, we can think of other ways to describe the data that, at least the data that are currently available, are better described by this, let's call it, mosaic hypothesis. I want to stress that I do not claim that the sex binary is never relevant. Obviously, it is relevant in, for example, reproductive medicine. What I claim is that in order to promote our understanding of sex itself and its relations with everything else, we need to turn the sex binary from a taken for granted starting point into one of several possible hypotheses and test to see which best describes the data. So I want to thank you very much. And Gina?
Thank you very much. I'm impressed by how much you kept to time. We're going to have discussion and questions afterwards, I should have said at the beginning. So if you've got questions specifically for Daphna, she will be able to answer them afterwards. But I think that's an amazing example of the fact that what we assumed was a very straightforward question isn't a straightforward question, and something that we should be looking at very carefully. So thank you very much, Daphna, for that and for keeping to time. So without further ado, I shall turn to Freya, who is writing notes. And Freya is from the Science Media Centre, and those of you who don't know, the Science Media Centre is an amazing organisation. It's an independent press office. You may be telling people more about it, but it actually means that when you do get fascinating research coming out of the journals, there is a kind of intermediary who will, who journalists and press offices can contact and say, you know, is there a briefing paper that, you know, we don't understand what this is actually saying, could you dilute it into words of several syllables? So I will find, I will find Freya's, is that somebody's phone? Is that mine? Sorry. Shows how well you kept to time. I'll switch it off now. Sorry. Right. Okay, sorry. We may need to go to... Sorry, Magda. What? Is it? Oh, there, in the file. Okay. Right, there we go. Thank you.
Thanks, Matt.
Right. I'll try and make sure I don't set the timer.
Brilliant. Thank you so much, and thank you so much for having me on this panel. Just to really clarify, I'm not a researcher or a scientist, so I'm very much coming at this from the media perspective. But I do think that the media is an incredibly sort of important part of this, and the communication of this science and research is almost as important as the research itself because of the impact it has on public understanding. So I'm a press officer at the Science Media Centre, which is an independent charity whose aim is to ensure that the public have access to the best evidence and expertise via the news media when science hits the headlines. So we were set up in 2002 after things were going very wrong. So all of these stories on this slide here were sort of some of the biggest stories of the day. but there was a notable absence of scientists in the media talking about these issues, and they obviously, in all of these stories, had an incredible wealth of expertise and could speak to the evidence, which really meant that the public were missing out on sort of getting access to some really important evidence and science and expertise on these really important issues. So we were set up in 2002 to try and better bridge that gap between the scientific community and the research community, and so we've been doing that ever since. So, as I said, we're an independent press office for science. Specifically, our aim is to improve the accuracy of reporting, not the quantity, and we really focus on the messy, controversial topics, breaking news and scare stories, because we really think that is where it's absolutely most important that the public have access to the best evidence and expertise on those issues. So it might be something along the lines of diet and nutrition, it might be risks of certain common or rare diseases like dementia and cancer, or perhaps motor neuron disease. It might be whether you should let your child use an iPad or not, whether you should switch to e-cigarettes from cigarettes to stop smoking, and of course how we understand the differences between men, women, girls, boys, and their brains and their psychology, which is the topic of this evening's event. So I'm going to talk first about sort of our main strategies and give a couple of examples as well to hopefully sort of demonstrate how we work, and then add in at the end a few additional points sort of around my thoughts on this topic more generally. So firstly, rapid reactions. This is when we respond to breaking news stories, and we really see that science in the headlines is a huge opportunity as well as a threat. So we monitor the news, and when there's a story that pops up where we think science and experts can help the public navigate a story, we go to our expert database and we try and get them to send written comments to help explain the situation and what's going on, and share those with the national news journalists, and they can use those comments in their reporting. So yeah. Topics on this might be a disease outbreak, obviously big COVID announcements, it might be the ONS data on excess deaths, extreme weather events, disasters, so often quite scary stories, but it helps the public navigate them and equally helps the journalists report on them as and when they're happening in real time. And this is a very, very quick aspect of our work, so we need really quick responses from the scientists. I'm not going to show an example here because I'm not sure this is quite the topic that tends to get sort of those big scary stories, but who knows, that might happen one day and we'll be ready to respond. Next up is roundups, and this is really sort of the bread and butter of our everyday work, and it's something quite unique to the Science Media Centre as a press office in the UK. So we receive press releases from the top journals, universities and funders at the same time as journalists do, and we identify stories we think could be sensationalised or misreported, and we seek third-party experts to provide context and to guide journalists during the embargo period where they're deciding which stories to write and sort of how big to make the story and what kind of approach and top line to go with. So we do all of this under embargo, so just sorry if this is a real oversimplification and you all know this already, but so much of research news enters the public domain via the news media through this route. So you'll write a paper, you'll tell your press office with a lot of notice, hopefully, and they'll write a press release and it'll be sent to the journalists under embargo, and then the journalists have a few days to write it, and once the embargo lifts, it'll be published online and in the papers, and the public then can read about the research. And we come in at this point here. So just to give an example of this in practice, this was a press release released on a paper in JAMA Pediatrics. It was looking at fluoride exposure during sort of pregnancy and IQ in their children, and the top line sort of promoting the press release was about an association seen with higher fluoride intake and lower IQ in boys only. So obviously we thought this is quite an interesting story, we think the media might be interested, I think a journalist maybe even flagged it to us, so we went to our expert database with the relevant expertise and said, right, can you have a look at the press release and the paper and send us some comments and your thoughts. The kinds of questions we tend to ask will be like, does the press release reflect the paper? What's the sample size? Is it sufficient to provide good evidence of a result or a finding? Is it an observational study? Can it demonstrate causality? Is it a study done in cells, in animals, in humans? Is it a clinical trial? So all of these questions that can really help journalists navigate how significant and robust this new study is, and that you can use that to guide whether they choose to write the story and how they write it. As you can see, they weren't hugely impressed with the study. I'm not expecting you to read all of the words on the slide here, but just to sort of say, they really picked up on this sort of sex difference increase and suggested that it was a subgroup analysis, and it could be because the data are very noisy. They've just found a single association and really gone with that and made that the top line finding when there's not a huge amount of evidence that's necessarily a real result. Again, a few more comments, and you can see from a range of different types of expertise. Someone with expertise in toxicology suggested it would be very, very rare to see such a different effect a significant and non-significant effect in the different sexes. Some cognitive scientists sort of spoke about there being some real outliers and whether the result held true once those severe outliers were removed. And just there's no pre-registration of the study, so we don't know whether the decision to split it by sex was done post hoc to find a nice positive finding. So we sent all of these comments out to journalists, and overall there was not a huge amount of coverage, which sometimes is quite unique for a press office. We really like when there's not coverage, when a story perhaps has quite a lot of flaws or isn't necessarily badged as what it was originally intended to. But as you can see in the few articles where it was covered, it was really clear that this was potentially a controversial study, and the criticisms and sort of the highlighting of potential flaws were very, very prominent in the coverage, which was really good to see. I think anyone reading about this study would know that there was not a general consensus on what these findings were able to show. Next up, I'm going to talk about media briefings. So these are really great, and it's an opportunity for scientists to help set the agenda and speak about their research in a bit more depth and detail than a press release alone. Often we do them on new, important, significant studies, or also background briefings on big areas that the journalists are writing about a lot, and we think it would be useful to speak to some top experts in. So this is an example of a media briefing we did. This is a lovely example, because we did it, I'm obviously going to say this is a good example of how you do this. So this was a paper in Nature Communications, and it was looking at social media use and well-being at different times during adolescence. And I'm sure you're all aware that that's a very hot topic in the media and in society, and there's lots of debates around the impacts of social media. And so we said, this is a really important paper, we'd like to run a briefing, and we think it's really important that it's reported on accurately, and the journalists have time to ask a lot of questions about the research. So the authors of the paper spoke to journalists, and were really clear that they had, and this is the attendees, so as you can see, a huge range of sort of the UK media attended. And I think what's really important to know is when there are sex differences, they're reported on accurately, especially if there might be concerning findings. It's really important that they're explained well, but they don't go above and beyond what the science is able to say. And at this stage, there was a sex difference seen in the vulnerability of social media use and well-being at different ages in boys and girls. So they spoke about that, but they were very measured and nuanced, and they did not go above what the study was able to show. They didn't explain why this finding was so it was. This was something that came out of the study that needed further research. They had few hypotheses, but they said further research was needed before we can actually describe why this is happening and whether there's a way we can help. So all of this was covered really, really nicely in the resulting coverage. And as you can see, there's really nice quotes about windows of vulnerability, and sort of written about, given the broad and complex changes that occur in adolescence, biologically and socially, the mechanisms may take some time to nail down. So it was done in a way in which it was really measured, but it did still emphasize that the top-line findings were a difference between boys and girls. And again, some really nice quotes from the authors to make sure that sort of they had as much sort of agency as possible to try and get the coverage as measured as possible. So just after that, I'm going to do a few final points and then wrap up. I hope this doesn't seem too glib, especially after sort of Gina's first comments around sort of why this is so important. But I just really wanted to say that often it's not the topic, it's the sex difference that's the story. So it's not just neuroscience. I was looking back through the last year's stories, and bar a few big COVID stories, this was honestly one of the ones with like the sheer number of places that covered it. And there was some great like espresso for him, cappuccino for her, whatever. It was completely, like, it was an observational study. They didn't account for any of the right confounders, but it was absolutely everywhere. And just to say that when you are being asked to talk about a study, or you are being asked around sort of what are the caveats and limitations of a study, it probably is really important to focus on whether those sex differences are valid or not, and if not, give a really good explanation as to why they might not be, or it might be a simplification of the picture, because that is probably the crux of the story, and that's the angle they're going to go for. So it's mainly just a reminder that this is a really important sort of thing that drives the news agenda to be aware of, and also it's a great opportunity. This is a topic, sex differences, that makes media a lot, and every time it comes up, it's an opportunity for you to talk about the potential pitfalls of research and the limitations that often come from this kind of research. It's not just the media either. I'm getting everyone out of, sort of the blame, but there was some really interesting research that came from Cardiff University in 2014 and 2016. And they looked at press releases from universities, and more broadly from sort of just science-related press releases. And they found that the exaggeration in use is strongly associated with the exaggeration in press releases, which might be slightly surprising and not as expected. People might want to immediately point the blame at the media, but if you can trace the source back to the press release, that's quite important to know and maybe quite telling. Equally, the second paper also found that there's no evidence of exaggerations or caveats increase or decrease the likelihood of news coverage, which is a very, very good finding. But I think here I just want to say this is something that should be a really easy win for the research community. Researchers get sign-off on these press releases, so scientists should feel confident enough to push back on a press officer when they say, actually, you're going above and beyond what the study is able to say. I know it's a nice, fun headline, but you should feel confident to push back on it. Equally, press officers should be able to push back on very overexcited scientists. At the SMC, we work with both parties to try and ensure that sort of the press release and everything that's done prior to being released to the journalist is as measured and accurate as possible. But that's not to say that we shouldn't be engaging with the media. It's still incredibly influential. It's still a huge source of information in the UK on health and science news, and we really say at the SMC, ignore it at your peril. So what we tend to say, what we should need from scientists on our database is honesty, no party lines, speak about the evidence, change your position as the evidence changes, and admit uncertainties. Basically, be a scientist. It's probably a role that very few others can fulfill in the media, but it's a really, really important one. Secondly, willingness to engage. Engage when you're needed, champion your subject and expertise, and make every story your business, not just when you've got a shiny new paper and press release. If your topic's been mangled or misinformed in the media, that's your chance to get in and engage and try and improve the general understanding of your area of expertise in the media, not just when it's your own research. Patience. You may need to repeat the same messages again and again. I'm sure the rest of the panel are probably very familiar with this, but we really do believe at the SMC that resilience is worth it, and evidence usually wins in the long run. So essentially, I just sort of wanted to finish with the SMC philosophy, is that we'll get the media to do science better when scientists do the media better. So I'm going to end there, and there's my contact details if anyone wants to follow up.
Thank you very much indeed, Freya, and thank you very much for being so well to and a lot to think about there. And I sometimes wonder if scientists are their own worst enemies. You know, they complain about the press coverage they get, and then you think, well, maybe you should look at what you wrote in the first place. Anyway, it's now my great pleasure to introduce Katy, Losse and Simon White, who are my team members, the team members who've done all the work. And they're going to be telling you about the outcome of this project, the Noise in Neuroscience project, which started really 2 or 3 years ago when I wrote with some other colleagues a paper about a particular paper, in fact, looking at height, saying that if we really look at this paper, it was about sex differences in the infant brain, and saying there are all sorts of problems with this paper, in particular in the narrative. There are some methodological issues as well, but if we look at the way in which the story was told and predicted the way in which the story would be spun, there are difficulties. So I suddenly thought, well, we need to talk to scientists to say, you need to be careful what you say, and we need to talk to journalists, to journals to say, you have very good guidelines which give us clear indication of making sure your reviewers check the validity of the findings, that the statistics are appropriate, that the methodology is sound, etc. But you don't ask reviewers to say, is this a reliable, is the narrative a reliable and accurate representation of what these scientists actually found? Bearing in mind that people who are not experts in the area will be reading this for their own interest, but also because it may impact on how they parent or how they teach, or even into government policy. So Simon and Katy have been working with me on this, and I say they've been doing all the work. And Katy will now be starting, I think, with talking a bit about what we found so far and what we're actually suggesting might be useful. And this is really where we'd like you to give us some feedback. I can't get this to come up.
Great. Thank you, and yeah, it's absolutely great to be here. An exciting event to be part of, and talk to you about this Noise in Neuroscience project that we hope can be part of the solution to the pushback that you were saying, Freya, is really needed, and we're hopeful that, as Gina was saying, this can be a really important part of doing that. So just a little bit about me. I'm Katy Losse, and my day job is at the National Audit Office, so I'm at the UK's spending watchdog. So my interest here stems from a sort of personal experience rather than professional, from encountering this kind of neurotrash that Gina was talking about in my own personal life, being taught to my 10-year-old daughter, and being really frustrated about how hard it is to get underneath some of the hype and exaggeration here. I'll talk a bit about the project that we've been working on that we hope can be part of the solution, explain why we think, we're, as Gina was saying, the aim is to come up with some good practice guidelines, and I'll say a bit more about why we think good practice guidelines could be part of the answer, and the framework that we think we could base those on, and then I'll hand over to Simon, another member of the team, who is our statistics ambassador from the RSS and working with us on it. He'll talk about actually what's in those guidelines and what do we think they might cover and where might we go next with them. So before I dive into the practicalities though, I thought I'd start with our logo, which is on the right-hand side there. And it's an optical illusion, so there's 3 brain images there, and they're all the same colour, but the ones on the left and the right have got overlapping lines, so green overlapping lines and red overlapping lines. And what happens is that those lines distort our perception of what's underneath. You can see it a bit easier on the right-hand side, so when you put the green lines over, the brains themselves look green. When you put the red lines over, the brains themselves look green, but the actual underlying image remains the same. It's based on an illusion called the Munker-White illusion. And for me, there's an analogy here for what we're trying to do with this project. And it kind of sums up for me what we want to achieve with this piece of work and why we think it matters. Because, I think of these overlapping lines as being the hype and exaggeration that distorts how people interpret the evidence about sex, gender and the brain. As we were hearing, it's just people are really interested in it. There's a deep cultural fascination with this, and it can easily get hyped. And actually what we want to do is try and help cut out some of that, make it quicker and easier to cut out some of that noise and get to the truth underneath. So why do we think good practice guidelines is the answer? As Gina said, it's really about the fact that there is this road to neurotrash really starts with can start with the original research. It's not just a problem at the right-hand side of this chain of communication. It can start with the original research paper, and there's, as we were hearing, a lot of research on sex, gender and the brain. We reckon 9,000 academic articles on sex, gender differences in the human brain over the 2 years, 2020 to 22. And it's, as we were hearing, it's communicated by and to non-experts because there's this deep cultural fascination with what that means for how we relate to each other as men and women. And we estimate, we think there's 9,000 articles in the popular media over the same time frame. So it's absolutely huge, and it really raises the stakes for how accurately and carefully that evidence is explained for a lay audience. But there's no guidelines, existing guidelines at the moment for authors and reviewers. As Gina was saying, there's nothing that focuses on the narrative sections of a paper. So there are guidelines for authors and reviewers about sort of accuracy and methodology, but there's nothing about the impression that creates for a reader. And as I say, this is research that's being read by non-experts and being interpreted by non-experts. The other reason that we think good practice guidelines could be really important here is because it's a whack-a-mole problem, which is how Gina described it in her book, The Gendered Brain, which I would highly recommend. As soon as one misleading public claim is kind of knocked down, another one pops up, or the same one pops up, just in a different form. And actually, that kind of, there's lots of people doing diligent work to kind of knock these claims down, but they just keep popping up. We think having a kind of authoritative, agreed, clear statement of what good looks like in communicating research on this issue is really helpful for prevention as well as cure. So in my work at the National Audit Office, we're very fond of lessons learned, good practice principles. We produce these kind of good practice frameworks. And actually, that really, I see the benefit that has in terms of cure. So it makes it much easier to identify what the root of a problem is and explain that. You have a kind of a north star to be able to get to the heart of an issue, and you also have a common language to explain to other people, so it's quicker and easier to find a problem. So that kind of patience, resilience that Freya was talking about that's needed, to just keep saying the same things, it's much easier if you've got a good practice framework to refer to, we think. But also we hope it's part of that culture change. So as Daphna was talking about, that kind of culture change about how do we talk about this in a responsible way and get beyond the kind of assumption that we're starting from a male-female binary and we're trying to disprove something that's already been shown not to exist. So I think that we hope it can be part of that sort of culture change that raises the standards and expectations about how you talk about these things. So in terms of the basis for our guidelines, just quickly, and then I'll hand over to Sam to say more about what they might involve. We were thinking about how do you come up with a framework of good practice here, and we had lots of fun playing around with different acronyms. We thought an acronym was important. We came up with lots of terrible ones, and we decided that actually, we came across this existing framework called MAGIC, and we wondered if actually adapting that is the best way to go. So this is a framework, I don't know if people are familiar with it. It was proposed in a 1995 statistics textbook by Robb, Abelson. And it's about how do you develop a useful argument from quantitative evidence. So the purpose of it is how are you persuasive whilst remaining true to the data. And we think that's the key here. It's kind of those two things together. Absolutely, we want to tell a story. People are interested in this. But how do you do that in a way that doesn't go beyond your data? A principled argument, he described it as. And also, I think what's helpful about this is it was always intended as a way of critically evaluating another's claim. So it could be something that people use to sort of say, do I believe this claim? So we've translated those MAGIC criteria into what we think might matter most for responsible impression management in this area. And you can see those guidelines on our website, and we'd really welcome feedback on those. We definitely will need to keep iterating how we describe them, and we'd welcome your feedback on that. But I'll hand over to Simon, who can talk through some examples of the issues that we think it might cover.
So it might be a weird thing to say in the Royal Statistical Society, but our guidelines, you'll note, aren't really about the numbers. It's about how the numbers are presented. It's the story. And we talk a lot in stats about telling stories, and that's how we get our papers from a purely academic sense into the media. People like to tell stories. Numbers become stories. The problem is sometimes the story becomes a life of its own, a legend, if you will, and no one looks back at the original data. And that's the source of particularly this sex, gender, and neuroscience issue, where a lot of what the public perception is based on, falsehoods might be a strong term. Bad science, perhaps is a stronger term, but misrepresentation, particularly of older studies 20, 30 years ago. But people don't go back and check. And this isn't just a problem for non-scientists, it's a problem for scientists too. Because we haven't gone back and reanalyzed any of these old assumptions. They're just part of the global psyche. So really, what we were thinking with our guidelines is not just the methods. Again, as the statistician, it's not just about the stats. It's about how we communicate that and how we present that. And really, one of our key ones in there, the M, is the front. Really, we did play with the acronym a lot. We're very happy with the acronym. No, we're not changing it. The M is magnitude, and it's difference. And I did nothing. Difference. It's a weird part of the human psyche that we're obsessed with finding difference. And arguably, this is one of the fallacies of science. We've set up the scientific way of thinking to try and find differences. And it's all about that idea without conceptualizing what that might even mean and whether the difference matters. My favourite example of this is the Brussels sprouts and cauliflower. They're very, very different. But if you ask a scientist, they're exactly the same, because they're the same species. Obviously, one is better than the other. I won't get into a debate about which. But right there, it's a spurious example, but they're different in some common sense, but in a scientific sense, they're identical. Now, how do you present that in a meaningful way? What does that difference mean? And this is essentially one of the issues we have. And I know my joke about this was stolen, but I'm going to do it anyway. The average person in the UK has one testicle and one ovary. The typical person is very different. And, I have to put a stats joke in. But, what does that mean when we are talking about what differences are? Because even if you accept the binary view, which I don't, and you have male and female, you've averaged all males and you've averaged all females. So if you weren't happy with one testicle and one ovary, why are you happy with averaging all men together? And all women together? I mean, you can keep dividing down. The principle of dividing, if you're not going to think about the commonality, if you've come at it going, I must find a difference, well, we can keep slicing those populations into smaller and smaller groups, and you can always find a difference somewhere. Cat lovers and dog lovers, and then the people who like reptiles and tarantulas, they're weird. But that's why difference is, and we used magnitude because we really couldn't find an acronym with D at the front, but magnitude and differences, it's fundamental here. What are we trying to get at? What is the story we're saying? And is the difference something that has any meaning? Later on we get into the idea of the stats, is this all by chance? Have we just found a difference because we've been looking for one? Again, you can always enumerate many characteristics, and eventually you'll find something that's different. But did it matter? And the final one there is the impression and the explanation. Just finding a difference doesn't mean it has any actual important explanation. There could be differences for reasons you haven't measured. The RSS tagline is data, evidence, decisions. If your data doesn't include the things to enable you to make an accurate decision, then you've already started off on a bad foot. So if you found a difference on a measure, that's great. But if you can't explain that measure, that difference using something else you've measured, then what does the difference mean? Differences alone are meaningless, but you can tell a story about a difference. Sometimes you forget to explain why the story has a point. In terms of how we're going to go forward with these guidelines, we have a couple of challenges. The first one is, why focus on this? There are lots of other problems. The reporting of climate science, the reporting of many other areas of science. But all of these areas need to be addressed. But sex, gender, and neuroscience, it's got such an impact on how people perceive many areas of our society and policy that, it's better to start. And I'm not saying we should ignore the other big problems, but listen to us, we spent time on this problem needs work too. In terms of guidelines, and, are there too many guidelines? I think if you work in sort of medical publishing, there are the Strobe and the Consort guidelines, which we've got as ways to report for academic studies. So what does MAGIC bring? Well, one thing it does is it focuses on the interpretation. The Strobe and Consort guidelines are very much on the definite reporting and, are you reporting your p-values, are you reporting your confidence intervals? And they kind of omit, well, they don't, they have one checkbox for what does this mean and is it important? So what the MAGIC guidelines are trying to bring is reflecting, some self-reflection from the scientists and from the editorial process about what does this mean beyond just the paper. And I think this circles back to an important point that now in the era of open publishing, all of our papers are hopefully going open access so anyone can read them. And that's a good thing. I don't mean that as a bad thing. It's a good thing that all our papers are open for anyone to read. But that means that we have to be even more careful about what that last paragraph of the discussion says. Because if it's off in the clouds, as many I want to do, hands up, I've done it as well, then what impression do we leave a reader who's only going to come to that one paper because that's what insert name of random search engine got you to? That's where we are. So hopefully going forward, we think that there is a space for these magic guidelines in the process, both at the scientists, at the editorial, and more broadly going out into science writers and the whole chain that we've been discussing. And we think that there is definitely a need for them, and it's not just another set of guidelines. It does fulfill a utility that hopefully people will appreciate. And then hopefully we'll get rid of the noise, or at least have a bigger mallet.
Thank you very much, sir.
I believe in my editorial career, in 16 years I've been doing this, I believe as editors, as publisher, our mission is to ensure scientists are really transparent in reporting what they have thought about, what they are doing, but they also sort of the impact of afterwards. And in the open access sphere that we are now, that Simon presented, is really very important. Anyone can look at any paper we publish at our journal at Nature Communication, and I don't think most scientists don't realize what this means, basically. Okay, so I'll just say a little bit about how do we approach sex and gender reporting at Nature journals in a sensitive fashion. And as you will see, the message is that there is a little bit of a conflict because there is a need to do more of this research in many, many spheres. What happened during COVID-19 pandemics was one of those things as well, that people had not looked at that dimension very much, and that could be a problem, and many other spheres. But there is also a way of not saying too much, as we have all discussed and presented already by others. And unfortunately, at the moment, most people still think in terms of this binary thing, even if there are ways, of course, and thankfully for people to identify themselves according to different gender. When we look at things at the level of biological characteristic, we're not there yet. However, I think doing this reporting very detailed, explaining the method and showing all the disaggregated data can help people like Daphne to do their research then and go back and analyze it in a different fashion, I would say. So what we first think about at the Nature Portfolio Journal, within Springer Nature itself, that we think that, the problem starts with who is doing the science. Still, my daughter is 23, she is at the computer science degree, 250 people in her course, only 40 girls. This is appalling. So we think that as editors and publishers, we have a role to play in ensuring that we get more diversity in the people doing the science itself, because that is the only way that the right questions are going to be asked and then reported. And we utilize our publishing platforms to give a voice to a diversity of scientists, but also to have everyone explain what do they think we need to do to move forward. Also, when we do conferences, we really ensure that there is a diverse representation of speakers, and we don't participate to anything where there is panel, so only a panel formed of men. And then we had our own conference on what to do about breaking gender equity. And then we also have content, which is looking at those matters. So in terms of how to do it, there are lots of research showing that, perhaps the wrong medicine were prescribed to women because we didn't have enough data. And we didn't have enough data, even if many funding agencies have been asking for inclusion of, the correct population in their studies already for many years. There's, still 27% of studies only look at male subjects in many different topics. And then even when people are using both subjects, they don't quantify the sample size by sex, they don't analyze it properly with the thinking before they start the study. So what we've done last year is we're sort of raising the bar in terms of what we expect people to be reporting in sex and gender in their research. And there is a set of guidelines called Sex and Gender Equity in Research, which we have been mentioning in our guidelines for authors, but we've not really looked at what people were doing. And so last year we really dedicated a box into a sort of reporting summary. People have to complete if they are to submit a paper to us, which has a complete section on reporting on sex and gender. And few of our journals are doing a pilot where we're trying to go one step further, ensuring that it's clearly stated in the title and abstract, also not only when you're reporting, but in the study design. So have you thought about it before you started? Very importantly, also should refrain from conducting those post-hoc analysis, which I think is the subgroup problem is very prominent and prevalent in there. And then justify reasons for lack of sex and gender-based analysis. So this seems all good, and hopefully, if people are reporting their data points as well, then people like Daphne can go back and look if any difference was meaningful or not. The problem is that we may then encounter a conflict here, because it's very important, but it could also mean that people are highlighting more those differences. So what to do about that? What to do to prevent that to sort of become what is talked about? And so last year also, in parallel, we were developing another framework, which is to look at how to report research in a way that no unintended harms can be produced. And normally, of course, when you involve a human research population, you have an ethic board, which is looking at are you going to cause any harm, or fully not, to your human research population. But very rarely, or I think I have not seen an example of that yet, the ethic board is looking at what impact the result when published could have on the broader population. So not only the one you have studied, but any woman, for example. And that's really much because of the narrative of the story that could change completely. So we developed this guidance, which is not only looking at potential differences in sex and gender, but also underrepresented population. And so hopefully this will help with this. So, so the guidance is really about minimizing potential harms that could be happening because of the way you report. So it's similar to the magic thing, I think, in a sense. And I mean, I'm not going to go through this, but there is a really very nice editorial published by Nature Human Behavior, where they have some examples of fictitious cases where applying those guidelines can really help to have everything presented as we hope it will be. And I was really pleased to see Freya's paper, because that is one paper where our editors went through this. So what, I'm sorry, this is like I should have stayed studying potential differences between people. And so we do have, in parallel to this external guidance, we have an internal guide for editors, which is for them to identify those topics. It can be a little bit tricky sometimes, because as you said, this espresso coffee study doesn't look like could be harmful, but could be. And then to ask also really to be mindful of consequences when they are claiming to establish causal inferences. We ask them to remove those claims when appropriate. And very important is, and because of the open science as well, I think, is to be very clear to describe any operationalization that has been done in the research study, because oftentimes scientists use terms which have a very precise meaning for them, but actually the broader reader is not going to understand this meaning. I mean, today I was looking at one study where people were talking about mouse consciousness when they mean mouse wake, and so we have to ask them to remove that type of things, of course. And then we also be very mindful of the statistics. So, and then I'm just going to thank everyone, especially Stavula Kusta and Soumya Swaminathan, who are responsible to develop a lot of those policies as well at the portfolio. I hope.
Thank you very much, Nathalie. Thank you very much, Nathalie. Thank you. Hoping there's a magic-shaped hole in that nice list of suggestions. And finally, to Hannah Devlin, whose name I'm sure is familiar to many here. Hannah is the science correspondent at The Guardian, previously with The Times, and most recently has been writing about chocolate and shouting dolphins, I think is something I've been reading about. And I have to say, whenever I see some paper that's been published which is talking about sex differences, I think, oh no, here we go, last truth. When I see that Hannah's covering it, I usually feel that I can relax. So anyway, Hannah will perhaps tell us a bit about the challenges for her part of the profession in dealing with what we scientists come up with.
Yeah, thanks Gina for the very kind introduction, and I've got no slides, but I'm happy to talk. So I think with this topic, it's, as some of our speakers have already mentioned, it fits into this bigger cultural question about male and female roles, the experience of men and women, and this idea that the brain might be able to explain some of that and the differences we see in society is just inherently such a fascinating question. And I think, you know, the brain itself also holds this kind of fascination, and it's such an enchanting subject in itself. I think when you bring those two things together, and you have such a high level of interest in a topic, from a news point of view, what it can do is kind of lower the bar for how good a piece of research has to be, how compelling a piece of research has to be in order for us to cover it, because there's such an appetite. And my editors will, you know, maybe see a headline and be, you know, automatically interested without reading any further. So what sometimes the challenge is for me in this kind of area is actually talking things out of the paper rather than covering every single piece of research that comes out. I think when it comes to news as well, there is a difficulty, and Freya kind of touched upon this, in getting across the difference in how convincing a piece of work is. So you can have a study with, you know, maybe 20 people, an fMRI study that's, you know, maybe this sex difference popped out as a incidental finding, and then it's kind of reported and massively extrapolated, versus the kind of research that Daphna's talked about, which is, you know, been incredibly well thought through. It's been, you know, designed specifically to address this question, using, you know, very careful methods. And, you know, although we can do what Freya described and have comments from other experts pouring cold water on it, I still think once something makes it into the newspaper, once the headline's there, it kind of lends a degree of credibility and authority to the work. Even when you have those dissenting voices, it's still going to come across as, you know, there must have been some value in this work for us to have reported it. So I think that's one challenge that we're faced with, and it's not always very easy to communicate in, you know, the kind of pieces that I write. I think it's brilliant that this initiative has been set up, because I do feel as though it's been, over the years, it has been an area where both the science and the journalism has fallen short on quite a lot of occasions. And I think, you know, for me, the best journalism is work that tells you something completely new, that challenges what you might have thought about a subject, or gets you to look at a subject in a slightly different way. And I think that's true for science as well. And it's really, you know, the most valuable science is not stuff that just confirms your intuitions about a subject. It's you know, what the scientific method can bring is getting you to look beyond what you thought was there. And, you know, I thought Daphna's work was a really nice example of that. She's kind of showing that all of this previous work had been assuming this framework for having a male brain and a female brain, and then you were just trying to kind of illuminate that with looking at a specific thing. Whereas, you know, she's kind of questioning the whole framework and getting you to, you know, look at the entire question in a different way. But I think, you know, what is the case for a lot of these studies and a lot of the coverage is that it's actually, you know, it can be quite lazy in a way, not asking you to look at something in a new way, but actually just confirming, you know, people's prejudices. It's sort of acting as a reassurance that, you know, it's perhaps okay to hold these stereotypes because, look, we've found evidence of this in the brain. And I think that is, it can be really quite harmful, because, you know, we've seen people have held a lot of these prejudices and stereotypes about the male and female brain, you know, for centuries, and the kind of continued publication of work that isn't of the highest quality and that hasn't really robustly tested the claims that they're making, I think it just can perpetuate those stereotypes. And we've seen it. It's sort of even very educated people who have kind of maybe read up on the science. People like the case of the Google employee who was fired after saying there's no point in having diversity training because men and women are just simply different. There was a head teacher who gave evidence to a select committee inquiry last year suggesting that fewer girls doing maths and physics A levels wasn't necessarily a problem that we should be trying to we shouldn't necessarily be trying to alter those statistics because research shows that girls are just less interested in these subjects. And so I think it can be have quite a negative impact, and Gina touched on that too. And then I guess the last point I wanted to end on was more of a question really for the scientists, and I think it'd be one that I'd be interested in hearing, is really how some of these studies come about in the first place, because some of the results, it's hard to see how you could really interpret them. A lot of these studies can't show you whether these differences that showing up are innate differences or whether they're the result of different experiences. They're not always statistically powered to show what they're claiming to show. So I'm just curious of whether this kind of falls into the bigger replication crisis subject that is sometimes talked about in psychology, and whether it's this kind of pressure to publish that means sometimes people maybe set out to look at one hypothesis and maybe publish on that, and then because they've got the sex data in there too, they just kind of get a second hit by doing a publication on the sex differences, or maybe even the thing they set out to look at doesn't work out, and but then there's a sex difference, so they can get a paper out of it from that route. So I'm just kind of curious about, whether how some of these papers come about in the first place.
Right, okay. I'm going to exercise chairperson's privilege by actually answering, hopefully, Hannah's question first. How did this research get to be done? And I think there is an issue in this area in particular, that there's a lot of post hoc research going on. And I think the paper that originally sort of started this train of thought, that was part of what was going on. There's lots of research which is being done which is not designed to ask sex gender questions. Big lab, lots of postdocs and PhDs looking for papers, do a big study, come up with something, or maybe don't come up with something, and somebody says to a hapless postdoc, check and see if there's any sex differences. Because it's actually quite easy to do. Obviously, if you've been working with a mixed group, you can say, let's just quickly check the sex differences, and something might come out, and it's a publication. And because it's a publication that's popular, because it's about sex and the brain, then that gets to be a publication. And very often, two things. First of all, that lab in itself may not be set up for looking at sex gender differences. It may be completely different. Maybe developing a particular kind of methodology, for example, looking at brains in fetuses. So what they will then do is draw on an existing body of evidence to say, oh, well, this is what people think the differences between males and females are. They won't even think that, maybe we shouldn't actually be looking at them in this sort of binary way. There is a kind of given. And so there's a straightforward kind of statistical model, for example, applied to these data. And if you find a difference, it's likely to get published. And more worryingly, actually, having done that and not found a difference, then that doesn't get commented on at all, which means that there is a huge below the water part of the iceberg, or something stuck in a file drawer is another analogy, where there has always been an assumption that there are differences, lots of research reporting differences, very, very little research saying that actually there are more similarities than there are differences. Some of that's coming out. But I think that's the case. So I think that's another area which makes this difficult.
Could I jump in on? So
Yeah.
one other thing I think is how we train scientists.
Yes.
So one of the things we're very good at doing is lazy. We'll find something, we'll go, oh, there's a sex difference, but we don't have the time or the money to find out why, so we'll put it in the discussion and leave it to another scientist later on to work out whether it actually meant anything. I think that's where a lot of these, it's kind of, I don't want to be as pessimistic as Gina on this. I think people aren't doing it necessarily with any malice about it, but they go, oh, we found this sex difference, don't really know why, there's no causal belief in that one paper, but we'll just leave that as a point in the discussion. Hopefully someone else will pick that up in a few years and then try and say, actually, did that have any rational explanation?
Yeah.
And no one ever does. And then that's the only thing that's left in the record, and no one ever refutes it. I think there's a belief in science that we'll come up with ideas, and then hopefully somewhere down the line someone will refute it. But I think we're coming up with a lot of ideas, and there's not enough people refuting them later on. I think that's the gap in the science literature. If I was going to be big picture about it.
But I think one way you could say, this is completely correct what you all said, and this is what we experienced too, and that's why I put in bold this aspect of the Sagol guideline, because I think that's actually the most important one, ultimately, that people are very careful when they make any conclusion on things a posteriori is very important. But I think potentially one thing you could do in the future to address it is for this type of research, maybe funders could say, if you're going to do a research which involves looking at that, you need to have a format called registered report. So this is a format where people have a study plan which is reviewed before they start, and then it's reviewed and accepted at a journal, and no matter the result, it has to be published. So the premises are your research question is important enough, is relevant enough, and you have the good study plan for it, and you just stick to that. You don't go anywhere else. That would be one potential solution.
I mean, that feels very rigid, and I didn't want to say that, if something interesting and unexpected pops up, you should just always ignore it, but I don't know, do you think that kind of...
Well, that is rigid, but it is rigid for this one. It is to be hypothesis-driven, but a lot of this should be hypothesis-driven rather than this a posteriori thing. And then it's rigid, but once you have the data, then you can do this beautiful work, which is you look back at the data, you have the data points, you can reanalyze it in a different fashion, and then you maybe, again, get it reviewed before you do it, I don't know, but you will just go step by step in that fashion. It's not that you are completely rigid all the time, basically. It's just much more organized fashion.
I want to add another level of complexity to this, because I think, why are we asking this question? And I think in your guidelines, this was very evident. I completely agree with the guidelines about reporting, but then why require everyone to study sex-gender differences? When, for example, in the brain, my work and the work of others showed that sex category explained a tiny, tiny percent of the variability of the human brain.
Yes.
So instead of investing all this time and money and effort and publication into this, something that we already know, that it's not relevant. And again, not because sex-related factors do not affect the brain, but because there are a set of many, many factors that interact to affect the brain. So sex category gives no information on the brain. And instead, we need to ask other things. So let's look for what does affect the brain. Maybe socioeconomic status, maybe education, maybe poverty, maybe things that we can actually affect.
Yes.
Sex category is more difficult to change. So I think this is a problem, that we live in a society in which sex category is so important socially that we cannot let go of the idea that it's also really, really important, the most important thing in the brain, in medicine, etc. And so for me, obviously you need to have males and females in your samples, yes, but whether you should add sex category as an independent measure to analyze, this is a huge question. And in the brain, at least the normal brain, I think you shouldn't, because what you get is is you get false positive results. And we see it in functional MRI studies. Each study reports sex-gender differences. I mean, not all of them, but some of them do. But they are never the same differences. Because you take two samples from a single highly heterogeneous population, and obviously you would find differences, but in each study you would find different differences. So I think this is the main problem. And one last comment, sex categories are a very bad proxy for many, many different variables on which men and women differ on average. And what we are doing is using this, so I'll just give you an example. So for example, let's look at the cardiovascular disease. If someone comes with a heart attack, then it's really important whether they smoke and how much, and do they do physical exercise, and whether they're overweight, etc. So would you like your doctor to look at you, see if you are female or male, and then assume that they know everything about you? So if you are female, probably you haven't been smoking, because women on average smoke less, you are overweight, and you don't do physical exercise? Or would you like them to ask you, have you been smoking, how much, do you do physical exercise, and let's go on the weight, and let's see whether you are overweight or not? Well, I guess the answer is obvious. So the same here. Sex category is almost never relevant. Maybe there are other factors that are relevant, but these are, as you said, we are all lazy. These are hard to measure. To measure your type of education, to measure your socioeconomic status. All of these things are differ on average between men and women, but we should measure them. They may be important. Sex category is almost always not important as is. It's only a proxy for other variables. Let's look for them. And I think in this respect, the editorial policy you have is problematic, because it drives scientists to measure this, and if they measure this, they will report evidence, and then we need to, we create a problem, and then we need to solve it, and say, but be careful when you report sex-gender differences, maybe they will be misinterpreted. Why study them in the first place if there is no good reason to do this?
I think, sorry, just to pick up on that, I think it's one of those interesting things about, again, not to be the statistician in the room, not going for sex gender in that concept, but what do you even mean by sex? So there are lots of studies that have shown the effect of sex on various outcomes has changed over the last 50 years, to which the answer is, well, obviously, because women were kind of excluded from a lot of things 50 years ago. And if you look at outcomes like educational outcomes and IQ, the way we measure it was based on, 100 years ago women couldn't go to university. To say that there was a gender difference in outcomes about cognition and education would be kind of obvious. We forget that, as you say, gender, it's not just that. It wraps up so many aspects of society, other health outcomes. All of that gets wrapped up into that one little binary variable you have in your model. So my question really is, as the statistician, what do you even think that difference is? What is it representing? And untangling that is a very complicated problem that we leave as the second paragraph in the discussion for someone else to fix. And I think that I agree fully that what even does sex mean in a lot of these models?
Nathalie, you had a...
Well, I think in the case of some disease, there is clearly a problem the way that, because of just what Simon said, we have not included women in the studies or in the development of the drug. So that's why we are basically being transparent of what's done without making an inference or any conclusion is important, basically. I think because, there are lots of studies looking at, when women have a heart attack, the symptoms that people have been telling doctors about heart attack completely different between men and women.
No, they are not completely different, but some symptoms are more common. This is the binary framework. Some symptoms are more common in women compared to men. And this is why I agree with you. We need to always have males and females. It's also good to have people from different ethnic groups and different age ranges, because we want to capture human variability. And obviously sex is one of these domains. But this is not the question. Of course we need to have all of these people in the sample. The question is, should we divide them by sex when we analyze the data? And this is where I said you need to have very good reasons to divide by sex.
Absolutely.
And if you have these good reasons, maybe measure the relevant factors, because usually it's not the type of genitalia people have. Maybe it's the type of education they have, whether they have STEM-related education or humanities-related education. I don't know, other factors. So if you think sex category is important, why do you think so? And then measure the relevant variables and then analyze them, and let's see. Let's progress beyond the assumption that sex category is the most important thing in everything that we, we are as human. That's the point.
Yeah, so but I guess those I just focus on those guidelines are much more comprehensive. There are also other things which are asked, and there are questions about why. If you are doing that study about this variable, then you have to have a good reason for that. That's clear. No.
I think what I'll actually do is open the questions to the floor with people patiently sitting here. I mean, I've got lots of questions, but we have got networking afterwards, so we'll hopefully do that. You have a question?
There's a question and a comment. My concern about, I'm glad to hear that you agree that we should have, equal representation of males and females in all studies. But I worry that you would, by saying you mustn't analyze by sex unless you have good reason, my worry would be you are missing opportunities. And I will come to the question, but my comment is that there might be something in the data that you will only know if you look. And if you've already collected that data and you've already got it back as a sample, then it's just a click of the button really to produce that result. And it might be minor, and I understand 100% that minor differences can get overblown within the problem that we're talking about. But it could be more significant than that. And, the risk of sounding like a cliche, I did read Invisible Women, and it was just a book full of examples where men and female, men and women, either our biology or our lives or our roles differed, but nobody thought to look, and so bad things happened. As a result. But nobody thought to look, so there were underlying differences all along. You don't know unless you look. And since we have the facility to look, I just think better safe than sorry, but look, see what it says, and maybe have guidelines on when do we bother making any noise about that. So that's my comment. My question simply is, how do we square the circle? Because I'm hearing on the one hand sex differences are overblown, but I hear on the other hand that we need to have information about, we need to have this balanced sample size. We need to make sure that our samples are representative of people that are interested. We need to have all these other variables, male, female, tall, short, cat, lover, dog, or all that. You've got all of that. Socioeconomic status, and we know we can look for interactions between. So how do we square that circle? How do we not overblow them, but how do we also not just miss some crucial information that could make a difference?
Can I ask that? Because there's a nice example in that book, which is seatbelts. How seatbelts were designed for men, so women are more likely to get injured in the collarbone. Now that's an example where including sex has a purpose and a utility. And I think the reason we come to it, there's nothing, we're not saying don't include sex, but appreciate that if sex is the thing you want to intervene on, then you've got a problem. Whereas if you're saying that, in terms of reducing injury in car accidents, we're not going to change people's sex. We're going to change how we design cars. Whereas some of the examples we're talking about, in like neuroscience, the idea is to make women better at maths, we need to turn them into men. That's essentially the logical conclusion of some of the science.
I thought the conclusion was women, we just have these poor...
But then what do we do with it? I think this is the ultimate thing. Is saying that the male and female brains are different.
Can I just intervene, actually, because I think there is another issue in that sometimes
just
it's not about change. Need to get to the wine, obviously. Is the idea that actually don't change it. You say, because men and women have got different brains, let's not bother with these diversity and inclusion initiatives. Because women are, like the head teacher was saying, no, girls don't like maths, so they're going to go off and not be mathematicians. I have to be careful about saying they'll go off and do something, because somebody says, what's wrong with that? But I think the issue is that sometimes the science is interpreted as saying, this is fixed, and so let's not bother with any of this. Great if you could say, well, let's change the seatbelt design, but I think sometimes there is that kind of tension, and that's actually why the research is of interest, because there's clear evidence showing that people who have what they call this essentialist belief are less inclined to engage with diversity and inclusion initiatives, because they're saying, why are you trying to make girls do maths when clearly their brains don't work the right way? That's obviously slightly hyping, spinning, or whatever, but you know, it's not too far from the truth.
I think there's also two slightly distinct issues of the invisible women idea of having a default male view of things, and so the importance of including men and women in studies. And you know, Daphna's kind of pick graphs, or I don't know what you call it, the mosaic thing, shows that there is, you know, you can see a distinction between the average kind of male-female pattern, but there's a difference between the importance of including men and women in studies versus specifically looking at the differences and whether that is important. And I think for me those are two slightly distinct things.
How do you know how important or unimportant the differences are if you want them to?
But you can see there's an average difference that might not be enough to tell you something important about an individual's brain, but if you included no women at all, that would shift your view slightly. So if there might be a difference that is not important enough to be able to tell you, like predict what an individual's brain is going to be like, but if you took all women out of all studies, you would be missing some information. So I think there's two different, for me those are slightly distinct issues. I don't know.
It's variation as well. Just because there's a difference between male and female on any topic doesn't matter if the variation within, again, it's, as I say, if you're happy to divide but you've averaged all men and averaged all women, then the variation within those two groups might dwarf whatever difference. Yes. So the difference doesn't matter when you go, you know, because just picking a woman at random might be more like a random man, but on aggregate they're different, but the different doesn't have any utility.
Sorry, I would just, can I see if there's any other questions? So there is. Sorry, Alex.
Easy question. Everything that you talked about is in the English-speaking world so far. I wonder if you have examples of what this is like across the rest of the world.
So you're asking in the research we've been talking about mainly in the English, well, a Western view of is that?
Yeah. So what's it like across the rest of the world, depending on those?
In terms of the science, or in terms of the media coverage, or in terms of the importance of what do you ask?
Does everybody have the same fixation with sex and gender differences? Is it reported in a similar way?
Nathalie, is this something that the Nature looks at? You know, do we have a very Westernized perspective of this kind of science, or any kind of science?
I mean, to some extent, yes. I mean, but that's because most of the science has been funded in there. I mean, I don't know how people look at that. You know, so we're trying very hard to get other studies from other parts of the world to be submitted to our journal. So at the moment, I don't think we have a very good. I don't have a very good idea on that.
I don't know. It's an interesting question. You wonder if it's as much of an issue in those cultures. Alex.
Hi. Well, thank you all for coming out. I'm glad we braved the cold. Some really valuable information here. Actually, it ties into what you were just saying. As a science writer myself as well, I mean, our pool of research is a little skewed because we have to dig deep and go further than the top ranking of Google searches and citations that you get. Right? You have to be critical about that. And to pretty much to what Freya numbers, and one to tell us the story. So it's a multi-pronged attack, and I think people in the media, editors, and press officers, editors and writers alike have a responsibility to really interrogate the data, and then what you were saying about asking the right questions, or was you, sorry, you know, ask the right questions of these reports. But I, do research myself, trying to find studies. It is very much the case. You are, as personally speaking, a little bit prejudiced about and apprehensive about studies that maybe don't have the amount of citations. So it is our job to then look at the data and try to understand sample sizes and the categories and the methods. And that's not every writer is trained to do, and I think that's where we need to maybe also focus. We can have all the checklists, but I think we need to get them statistically and trained and understanding the numbers and reading all of that. But there is a conflict between press officers of universities and trying to make sure that they are honestly and accurately reporting on this data.
Thanks. I'm getting waving. Sorry, I'm getting waving from the back, but there will be more time to ask questions once we have a glass of wine in our hands, so which will be quite nice. Just to finish off, perhaps I'd ask everybody, and this is something which came into my head when we were all talking, and I'll see if it works. You'll find out. Are scientists their own worst enemies? It's really in terms of why we're in this mess today, which I think it is worrying. I mean, I think the message is out there, the difficulties we have in saying to people, do you know the old ideas are actually quite wrong? And then just being accused of being a political ideologue and preventing, putting women's health at risk because you're telling people they shouldn't be doing this kind of research. So perhaps if everybody had a kind of thought, if I was, start with Hannah, sorry, starting with you. Do you think we're our own worst enemies?
Well, I think it probably is true that on this issue, most of the problems probably come before it arrives on my desk. So either in the research, the way the research is being presented in the paper, the press release, and so on. So in that sense, I guess there is something to that argument. But I also think that most scientists do set out to really try and answer what they think is an important and interesting question. And sometimes maybe the reasons these kind of lower quality publications occur and the press releases happen are more to do with structural issues, with the kind of pressure to publish, the impact of requirements of funding. So I think maybe it's some of those pressures that result in this stuff rather than the individuals themselves having wrong intentions.
Simon? No?
Yeah, I mean, I think the way we train, the way we train scientists and what we think science is for has changed a bit in the last sort of 30, 40 years. I mean, there's very much now, I think, the whole idea of impact as a measure of academic output is because people want to know that we're spending their money properly. We are spending a lot of public money to do a lot of research. Some of it should be useful in some sense. So I don't have a problem with the idea of impact statements. I think the problem is there are some structural issues in how it's been developed and how it's rolled out. But whenever you try and put a metric on something, it always goes wrong.
Okay. Katy?
I think for me, sort of coming to this, as I came into, coming across some misleading claims and then trying to tackle it, I was very surprised and quite shocked at how low the stakes were for, I kind of was surprised at the scientific community, I have to say, having, been trained as a scientist and then worked in other areas and then came back to it, that actually there wasn't more stakes about actually saying this responsibly and sort of taking this responsibly. And I do think there is something about changing the sort of the culture or the training or the expectations. So it's kind of like some ground rules about if we're having these conversations, these are what we all think is appropriate and responsible.
I really don't have anything useful to say about the research community in science because I'm not embedded in it. So slightly like Hannah, I'm going to maybe pick up more on the question around sort of the tensions between the two. And I just think everything from my experience in the sort of as a press officer is news values are different from nice, slow, incremental understanding in science as papers change and develop, and we acknowledge new differences and new ways of approaching. It's just what science is, and the news is different, and there will always be tensions there, and it's exactly why the SMC exists and why we're very, very busy. So I loved hearing all of the amazing science, and I think it will eventually become more mainstream, and we'll keep talking about it, but I think it is just a huge responsibility of the researchers. And I would also say on the whole, press officers at universities in the UK tend to write incredibly responsible press releases. So I think not just assuming they're trying to hide, there obviously is that, there's that sort of motivation, but it's about picking the right stories rather than just picking a tiny little piss-poor study and hyping it. Lots of universities have lots of amazing research, and they just have to pick the right studies that have that news value as well as the good, robust research.
Natalie?
I guess, yes, you do. I mean, as you know, from an editorial standpoint, for this type of study, you do spend most of your time to ensure that there is no overstated claim. You know, so from our point of view, we're not interested in overstated claim at all. Just the right question and a good method and proper transparency, I guess. But it is true that sometimes you do have to fight with people about certain statements, and it's a bit unclear why. And how to address this, I don't know, perhaps things like the MAGIC guidelines could help with this because people are focusing on other things and they really want to have some positive result, but we really don't care if the result is positive or negative. It just has to be a good question, and a good study.
Thank you for that. Yes. Daphna?
So I think scientists don't have good enough education outside of science.
Yeah.
Specifically, they are not aware of the assumptions that they have, the pre-assumptions that they have. So this is why we are sort of as biased, because we are aware of these assumptions, but the other people, they just simply, they don't have assumptions, they are objective, right? So I think that is one of the problems. And you ask, when we have a set of data, very interesting data, and we can ask millions of questions of these data, and why do we choose this one or not the other one? So it is important to understand our assumptions when we get to this data. And I, again, use the assumption that we think that sex is really important, so why not study it? But maybe other things are important, why don't we ask those questions? So I think better education for scientists of meta-thinking about science, of learning how to understand their own assumptions and not just assume that this is true. I think this is important, and this will help us pose better questions, because the question limits the answers that we can get.
Okay, thank you very much. Well, we are over time, and we do need to get to the wine, apparently. So I'd just like you all to put your hands together and thank our amazing